Hello class. This is lesson 6, where we will be continuing our discussion on addition, subtraction, multiplication, and division of functions. So, as a reminder, if we add or subtract functions, we just simply add and subtract their corresponding formulas. So, say we have f of x equals x squared plus 1, g of x equals square root x, then f plus g of x is just the formula for f plus the formula for g. And we could plug a number into this as well. Say we want to plug in the number 4. Then we say f plus g of 4, and we just plug a 4 into the above formula. Okay, so we have 16 plus 1 plus square root 4. 17 plus 2, 19. But notice we cannot plug just any number into this. What if we want to plug in a -1? What's f plus g of -1? Well, if we tried to plug it in, we have -1 squared plus 1 plus square root -1, and this is the problem here. Right? Remember, we're only wanting to plug in 0 or positive numbers into the square root function. So the problem was this number was not in the original domain of g. So we have to be careful about domains here. So actually the domain of f plus g, and this also is true for f minus g or f times g, it is the domain, or let me say it is the overlap of the domain of f and of the domain of g. Okay, so let's look at the previous example here. We had f was x squared plus 1. G was square root x. So the domain of f was all real numbers. We could plug anything into the function f. The domain of g is greater than or equal to 0, right? So the overlap of these two would just be 0 to infinity. That's where those two intervals overlap. And that's true for how f plus g, f minus g, or f times g. The domain would just be the overlap of the two original domains. And it's a similar idea for f divided by g, but we just have to be careful because when dealing with division, we cannot divide by 0. So let's look at a division example. Let's say we have f of x equals x minus 1, g of x equals x minus 2 over x minus 3. So if we're looking at f divided by g of x, well, that's x minus 1. Let's make this a little more interesting. Let's do the square root of x minus 1. So let's have f of x be square root of x minus 1, just to make it a little more interesting. Okay, anyways, we divide by g, and that's x minus 2 over x minus 3. Okay, so that's what the formula looks like when we do f divided by g in this example. But what about the domain of f divided by g? Well, first let's just look at the domains of the two original functions. The domain of f is, well, we have a square root, so we have to take everything inside of the square root and make sure it's greater than or equal to 0. So for the domain of f, it's all the numbers greater than or equal to 1. Or in interval notation, it's 1 to infinity. The domain of g, well, g is a fraction, so on the bottom it cannot equal 0. So the bottom here, x minus 3, cannot equal 0. We cannot plug in 3. So in interval notation, the domain of g is minus infinity to 3, or 3 to infinity. Now let me plot both of these two domains on a number line. So here's the number 1, here's the number 2, there's the number 3. Okay, so in red, I'll do the domain of f. Here's the domain of f. In blue, I'll do the domain of g. There's the domain of g. Okay. But notice also, when we do f divided by g, g is on the bottom, so g can never equal 0, or else it would be dividing by 0. So when we look at this formula here, we know x can never be 2, because if we plug in x equals 2 into this formula, we would be dividing by 0. So here on my number line, let's also make the note that we cannot plug in the number 2. This number 2 is off limits here. It's out of bounds. Okay. So now when we look at the domain for f divided by g, it will just be the overlap of the two original domains and the added condition that we cannot divide by 0. So the domain of f divided by g will be from 1 to 2, or from 2 to 3, or from 3 to infinity, which if you look at the above number line, we could plug in numbers from 1 to 2, because that's all these domains are overlapping. We cannot plug in 2, because then the bottom would be 0. We can plug in numbers from 2 to 3, because all these, the domain of f and g are overlapping. Cannot plug in 3, because that was a restriction here. But we can plug in from 3 to infinity. So this is the domain of f divided by g. So to summarize, if we have a function f, have a function g, we just look at their domains, find the overlap of their domains. Then we also have to make sure that we never divide by 0. All right, so I'll write that in words, what we just found out. The domain of f divided by g is the overlap of the domains f and g. And then we have one more condition. So and we request that g does not equal 0 because we divide by 0. Okay, so that is how we deal with f divided by g. So to summarize what we learned today, we could add or subtract functions just by adding or subtracting their formulas. And then you could plug numbers into it as well, provided the number is in the domain of both of the original functions. That goes for addition, subtraction, and multiplying functions together. When we divide functions, we just divide their formulas. And we could plug in numbers providing the number is in the domain of the original two functions and that the bottom function is non-zero. Okay, so that is all we have for this lesson. Thank you for watching.